We have some more questions here where we know a bit about the gradient or the slope, and we know a point that it passes through. So for example, we might know how quickly something is changing, and we might have collected one piece of data, one piece of matching x and y that lie on the line. Anyway, our job is to find the equation of the line, an equation where the gradient is 3 and it passes through this point. We have a strategy over here that I suggest, which is step 1, see if you can find the gradient. And sure enough, in this question, we know what the gradient, m, is. We know the value for the gradient. The question tells us that the gradient is 3. So we can write m equals 3. Now we can narrow down what the equation looks like, because you might remember that the equation of a line looks like y equals mx plus c. For this question here, I'm going to swap steps 2 and 3. I'm going to write y equals mx plus c. This is the equation of any straight line. But hang on, one of these variables we know. See this m here? We know what the gradient m is. M is 3. So let's substitute m for 3, or replacing m with 3. We'll write the whole thing again, but instead of m, we'll write 3. Everything else stays the same. So this is substituting 3 for the value of m. We've narrowed down what the equation looks like. There's only one letter, one variable left to find. To show you the situation that we have, I'm going to swap into Desmos and put that equation in. The equation says y equals 3x plus c, so I will write y equals 3x plus c. In Desmos, one thing that's really cool is you can see what it looks like for different values of c. So this line here, it's actually many different lines. Every different value of c represents a different line, and we want to find the one value of c that makes it pass through the point 1, 2. How do we do that? Well, in Desmos, we could plot the point 1, 2. And then I could just change this until, there we go. Somewhere about there. It's kind of hard to see, isn't it? So it looks like c is going to be about -1 or so. But let's see if we can find it without graphing it. We're going to use algebra. We've got this equation. This is the equation of a line, but we still need to find what c is. And we know that this point, this matching x and y coordinate, makes this equation true. So let's substitute this x and this y into this equation. In other words, we're going to substitute the point where x equals 1 and y equals 2, because this should give us another true equation, because the point lies on the line. If we replace then y, we're going to replace with 2. So I'll copy this formula, this equation down, replace y with 2, copy down the equal sign, copy down the 3, x is being replaced with 1. There's an invisible times sign there, so this is 3 times 1. And then the plus c, I'll just copy that down, because I don't know what c is yet. But here's the trick. Look, we've got an equation here with one variable in it. The equation has one letter. So now that we have a true equation with one letter in it, one variable, we can figure out what c is. I can replace 3 times 1. I can replace that with 3 and copy everything else down. Copy the 2, copy the equals, copy the plus c. Just replace 3 times 1 with 3. And now you can solve this using what we learned before. I'm going to do it a bit backwards. I'm going to get this plus 3, and it turns into a -3 on the other side. What's really happening is I'm subtracting 3 from both sides. And now to take 3, I can replace that with -1. So c equals -1. If you're not sure about this, go back to my solving linear equations videos, and that will help you out. Well, this is neat. For the equation of a line, we've figured out what m is, and we've figured out what c is. C is down here. So m is 3, c is -1. Let's write the equation of a line, y equals mx plus c, But instead of m, we'll write 3, so y equals 3x. And then we need to add this c value of negative 1. So y equals 3x, take 1. I mean, technically, the formula says plus c, doesn't it? So it should be like this. Y equals 3x plus negative 1, because c is negative 1. But if I have a plus and a minus next to each other, it's the same as a minus. So that's why we write y equals 3x, take 1. Because I am on a computer, we can check our answer. Y equals 3x, take 1. Awesome! The slope is, for every 1 across, it goes up 1, 2, 3. So the slope, or gradient, is 3. And the y-intercept is negative 1. And it goes through the point just as we required. Yay! We'll do another one. You might see why this one is a bit trickier. 2 reasons. Number 1, fraction. Number 2, negative signs. But we're just going to follow the same strategy. The question tells us the gradient. It tells us that the gradient m is negative 1/2. So if the question tells you something, write it down as an equation. So therefore, using our equation of a line, y equals mx plus c, that's always true for a straight line, and we can replace m with negative 1/2. So y equals negative 1/2 times x plus c. Now we need to figure out what c is, the y-intercept, and we can substitute this point here. We know this point with an x of negative 3 and a y of negative 4. We know that point lies on this line, so if I substitute these coordinates into that equation, it will be true because it lies on the line. So in other words, let's replace y with negative 4 equals, I copy down, the negative 1/2 I copy down. I've got a number and a letter here, negative 1/2 and an x, so there is an invisible time sign in the middle. So that is a negative 1/2 times x. I can replace x with its value, which is negative 3. Now, I am always very adamant that you need to copy down an equation and, change bits, but certainly copy down all the bits you haven't changed. Can you notice something that I've forgotten at the end? The plus c. I've forgotten to put the plus c. So always make sure that you check the equation and make sure, I've copied down the y and replaced it, copied down the equal sign, copied down that, I've replaced the x with negative 3, and the plus c, I haven't messed with that, I haven't changed it, I'll just copy it down. Now we can solve this equation. There are a few different ways to solve it. One strategy is you can figure out what this whole, I'll put a little pen around it, this thing here, this is a fraction multiplied by a whole number. A negative times a negative is a positive. 1/2 times 3 is 3/2. If you are not sure about that, then you might want to look at multiplying a fraction by a whole number, just to check that you're okay with it. Anyway, on the top, 1 times 3 is 3. Negative and a negative is a positive. And the denominator, the bottom, is 2. So that's where I got 3/2. The plus c, I haven't messed with it. I copy it down. There are a few different ways you can solve this equation. You can multiply the whole thing by 2 is a strategy. Or you can say, this term here, 3/2, that term is positive. When I move it to the other side, never mind, that's not how I did it. I did it by multiplying everything by 2. So I noticed that there's a fraction here, the denominator is 2. So the lowest common denominator is 2. This times 2 is negative 8. 3 halves, 3/2. If I double that, I get 3. And if I double this, I get 2c. So I've doubled each term here. And the reason that I've doubled it is because I wanted to get rid of that fraction. What's next? Now I can go into moving terms. I've got a term here, a term here, and a term here. I'm going to choose to move this positive term to the other side. So it turns from positive 3 into negative 3. The plus c, the 2c stays there. And now, let's move up here for a bit more room. Negative 8, take 3. I can replace that with negative 11. The right-hand side stays the same. Now I'm done moving terms around. The opposite of multiplying by 2 here, because I need to break this term apart. C has been multiplied by 2. The opposite of multiplying by 2 is dividing by 2. So in other words, C is a negative 11 over 2. Or in other words, negative 5.5. I don't think we would have been able to guess that from this question here. So this is the kind where you really need to solve it algebraically because it's difficult to solve it in another way. So y is mx plus c. In other words, we know m is negative a half. Y is negative a half times x. And c is negative 11 over 2. Whoa, what a monster of a question. Let's just check that because this is a monster of an equation with negative fractions in it. Y equals negative a half times x minus 11 over 2. And we wanted to check that it goes through the point negative 3, negative 4, which is there. And we also want to check that the gradient is negative a half. In other words, the gradient goes down because it's negative, tick, and it's a half because if I move across 1 unit, I go down half a unit, tick. So we've solved the question. Whew, that was a tricky one. Anyway, that is how to find the equation of a line if you're given a gradient and a point, even if you're given fractions and negative numbers. I hope this has been helpful. Good luck with the questions and let me know if you need a hand. Bye everyone.